Okay, now it's being recorded. Okay. Okay, guys. So let's talk about Module 5, networking and content delivery. Okay. So networking basics. That's the topic we're gonna see today. Networking basics, Amazon VPC, VPC networking, VPC security, Amazon Route 53, Amazon CloudFront, activities, label, and network diagram, design a basic VPC architecture, and there's a VPC demo, okay? And the lab is gonna be build your VPC and launch a web server. And also we have the knowledge check for that one as well, okay? So after completing this module, you should be able to recognize the basics of networking, describe virtual networking in the cloud with Amazon VPC, right? Label a network diagram, design a basic VPC architecture, indicate the steps to build a VPC, identify security groups, create your own VPC and add additional components to it to produce a customized network, identify the fundamentals of Amazon Route 53, and recognize the benefits of Amazon CloudFront, right? Networking basics, that's the section 1, okay? So, you know, if you have some basic knowledge of networking, you can understand that their computers communicate with each other, right? Computers communicate with each other. They are going to be one subnet. In the case of AWS, they're going to be put inside a one subnet, right? And then the other computer is going to be put inside another subnet. Two different subnets here, right? And in the middle, there's going to be a router that's going to be, routing the traffic between the two subnets. Okay? In AWS, the same concept is applied. Every subnet is going to have a routing table, right, to just distribute the traffic inside the VPC. Okay. Now this is how networks work. Computers communicate with each other through a router. Okay, because this is a network and this is another network, and routers where they just connect networks. Okay. This is an IP address. An IP address has 4 octets. In other words, 4 bytes, right? God, this is crazy. 4 bytes. And then every byte has 8 bits, right? 1, 2, 3, 4, 1, 2, 3, 4. So it's 8 bits, right? And that is a total of 32 bits, okay? The computer doesn't understand 192.0.2.2.0. The computer understands 110000000000, blah, 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 blah. The computer understands zeros and ones. It doesn't understand numbers like 9, 2, and 2. It doesn't understand that. It understands zeros, binary notation, okay? That's what the computer understands. And every single IP has 4 bytes. And I'm talking about IPv4, okay? IPv4 has 4 bytes, which is 4 octets, and every byte has 8 bits, and that's a total of 8888. That's 32 bits. And we can see here in the next slide. So IPv4 has 32 bits, right? And IPv6 has 128 bits. And this is hexadecimal, okay? Hexadecimal. And, hexadecimal is a little more advanced. It's the next generation IP addressing, okay? Because we're running out of these guys, right? Running out of these guys. So IPv6 was already invented, and it has millions and millions and millions and millions of addresses. So I don't think that in a lifetime we will get rid of this. I mean, we will run out of this, okay? But we're actually running out of IP addresses in IPv4. Okay? AWS supports both. The network identifier, the first 3 octets, they identify the network. Okay? and the last one identifies the host, in this case of 24. Now, when you see this 24, this is a CIDR, right? It's a classless interdomain routing. When you see 24, it means that the subnet is going to have 256 available IP addresses, right? But AWS would take 5. AWS would take 5, and then it's going to be total 251. If I come back to my console and I come to VPC, right? I will just create a VPC real quick here, right? Now I'm going to create a VPC. This is the default one, okay? I'm going to create a VPC. I'm going to call it my Saturday MDC VPC, okay? The CIDR is going to be 10.0.0.0.16. That's going to be a CIDR. I may have IPv6 or not. And by the way, this CIDR allows 65,536 IP addresses, notation 16. Okay. I want to say no IVPC. That's okay. And then this is going to be the name of the VPC, my Saturday, my NDCC VPC. The tenancy can be dedicated or default. I don't want anything dedicated because I don't want to have this for myself only. This can be shared with other people in AWS. Okay. And now I have my own VPC here. If I go back to VPCs, I have my VPC here. Beautiful, with this CIDR. This is the CIDR that comes with the default VPC. It's 172.1.31.0.0/16. Okay. Now I want to create a subnet. I have 6 subnets by default that come with the default VPC, but I want to create my own. Okay. So I'm going to select the VPC. I'm going to put this on, and it's going to be the one that I just created, right? And then I'm going to call it public subnet 1. Okay. And that's going to be 1 East 1A. Okay. I'm going to put the subnet in the availability zone US East 1A. The CIDR is going to be 10.0.0.024. Okay. That's going to be the CIDR. And then I'm going to create my subnet. Perfect. The subnet has been created. Take a look at this. What happened here? I said before that /24 is 256 addresses. What happened here? Why do I have 251? And I said it already, but I'm asking you now, guys. Why do I have 251?
You said Amazon has a 5th octet?
Amazon takes 5 IP addresses. Okay, so how many IP addresses that Amazon AWS takes from subnets? Okay. Okay. Let me take a look at this. All right, Amazon will take 10.0.0.0.0 is the network address, and this is standard. Okay, Amazon will take that one, which is reserved by AWS for the VPC router. Okay, Amazon will take that 2, which is reserved by AWS, the IP address of the DNS server. Right, Amazon will take that 3, which is reserved by AWS for future use. And Amazon will take that 255, which is the network broadcast address. Okay. In traditional networks, number 1 and number 5 are taken. But Amazon takes 3 more and reserves those 3 as well. So that's why instead of seeing in your subnets, instead of seeing 256, You see 251 because Amazon will take 5 per subnet. If I create another subnet and I'm going to call it now private subnet 1, before the other one was public subnet 1, and now the CIDR cannot be the same because they cannot overlap. This is wrong, guys. This is wrong, right? When you try to subnet this, it's going to tell you this overlaps the other one, the first one that I created. So I have to do this. Okay? And create it this way. And then this way will be fine. Okay? So now if I create it, I have now in my subnets, I have 2 subnets here, right? One is public subnet 1 and then a private subnet 1. And by the way, what availability zone did I choose? They're both in 1A and 1A. Perfect. That's perfect. But as you can see, it took 5 from this one and took 5 from this one. Okay? So now I'm going to create, for the other availability zone, I'm going to create public subnet 2. Okay? Public subnet 2. And now I'm going to choose 1 East B, or East 1B. Okay? It cannot overlap. Don't forget that this one has to be 2, right? It cannot overlap with the other ones. So now I'm going to just hit create subnet, and the subnet has been created. And now I'm going to create a public subnet 2, a private subnet 2, I'm sorry, private subnet 2. And this one is going to be in 1B, like the other one. The CIDR cannot overlap, so we have to do this. So, and now I just create the subnet, come back to subnets, and I have 4 subnets now that I created, right? And if you take a look, they don't overlap here. What this is .2, .3, .0, .1. So they don't overlap, okay? If you take a look at the IP addresses, it took 5 from this one, from this one, from this one, from this one. It takes 5 from each subnet, okay? So this public subnet, the fact that it says public, it doesn't mean that it's public. So none of these subnets are public yet, okay? So what makes a subnet public? Well, it has to be attached to an internet gateway, okay? So if you want to make it public, it has to be attached to an internet gateway. The internet gateway is what makes a subnet public. If it's not attached to it, then the subnet will continue to be private, okay? And what do we put in a public subnet? The web servers. What do we put in a private subnet? The applications with confidential information, the databases, okay? So that's how it works. So I created a VPC and created, inside the VPC, I created 4 subnets, right? One is going to be in availability zone 1A, and the other ones are going to be in availability zone 1B, okay? In other words, it will be something like this. Let me see if I can show you a little image here. That's my, okay, maybe this. Something like this, okay? Something like this. One is 1A, is 1B, something like this. And then we have the public subnet here, where you have the web host. And then you have the database here, which is the private subnet, right? Private here, public here. And then you have the internet gateway here. And then you have elastic load balancer here. Application elastic load balancer. Something like this. And the router here. Yeah. Okay, something like that. It's what we did here in our AWS thing here. Okay, so we're gonna have here 251 addresses in this little octet here, which is the host identifier. We're gonna have, this is the host. You can have from 0000 to 1111, and that is basically 251 IP addresses. Actually, it's 256, but AWS takes 5. So these are the only ones that will accept. And what tells me that? This /24 here. /24 is 256. Okay, so the numbers will just double down. Let me just open this. Okay, so if we have /32, that's going to be 1 IP address. Okay, 1 IP. If you have /30, it's going to be 2. Okay, if you have /29, it's going to be 4. If you have /28, it's going to be 8. If you have /27, it's going to be 16. If you have /26, it's going to be 32. 25 is going to be
64.
64. But something is wrong here. Wait, something is wrong here.
Is there a /31?
Oh yes, yes. That was why something was wrong, because 24 is 256. Cannot be 128. So 2, 4, 8, 16, 32, 64, 128, and then 24 is 256. Okay. As you can see, as the number decreases by 1, here it increments by 2. Okay, it's just a double. It doubles. Yeah. Okay. So if we have 23, that's going to be 512, and then you have 22, that's going to be 1024, right? And if you have 21, that's going to be 2048, right? And then if you have 20, that's going to be 4096, right? And if you have 19, it's going to be 9192, right? Am I right? Is that right? I think it is right.
What happened to 8,192?
Because when you...
No, because I see 9,000.
That's correct. That's correct. And then this one, 18. Help me with some math here, guys. This is going to be 16,000, 4, 8, and then 2. I think this is the way, probably. Is that correct? No. No, it's going to be 3. Is that correct? Mm-hmm.
Yes.
Yeah. And then you continue all the way to 16 when you get 65,536 IP addresses. Okay. So guys, in the case of VPCs, the slowest you can go is 28. The lowest you can go is 28, and the highest is 16. This is the range for a VPC in AWS. Okay? That's the range in a VPC. Okay? So here I put 16. That's the lowest I can go. Or I could have put 28. But 28 will only give me would only give me 16 IP addresses, which is very short. I mean, small. You need to hire a bigger network so you can allocate more IP addresses. Okay, so this is basically that number at the end here is going to tell me how many IP addresses you can allocate. Okay, so why? Because this number 4, it will tell you the bits that are fixed. And if you do this, 8, 8, 8, that's 24, correct? There's 24 bits that are fixed. So the only ones that can be done is this one. If it is 16, then these two will be fixed, right? It's 8 and 8, right? So that's how you can do it, guys. I mean, it's the way it is. Okay. Now, the OSI is the Open Systems Interconnection Model. Okay, that's when you see all the layers, right? The application layer, it means for an application to access a computer network. There you have HTTP, FTP, DHCP, LDAP, all these protocols, right, that are used. In the presentation layer, number 6, it ensures that the application layer can read the data encryption, right? And you have this ASCII and ICA protocols. Section 5 enables orderly exchange of data. And then you have the NetBIOS, and then the RPC. Then transfer, which is layer 4, provides protocols to support host-to-host communication, transmission control protocol, user diagram protocol. So these protocols that are used, guys, to understand this, you will have to take a little, some classes on networking, because this is a class itself, all these guys, okay? Number 3, routing and packet forwarding routers. This is the IP protocol, internet protocol. Data link is the transfer data, that's number 2, in the same local area network. Hubs and switches, MAC address. Physical, the MAC address is a unique number that every device has, right? And what it means is media access control. That's what this stands for, media access control. And that's a number. If you take a look at your computer, laptop, phone, printer, headsets, every device has a MAC address because that's a number that the manufacturer gives it. It's a MAC address, okay? And the physical link is the transmission and reception of raw bit streams over a physical medium, and then, ones and zeros, okay? So guys, you don't have to be an expert in this. You just have to know that there is an LCI model, Open System Interconnection OSI model, where you can find different devices in a set of layers. Every computer will have this layer. So let me see if I can find an image here. Just give me 1 second. Find an image that represents this a little bit better. Okay, like this. And we see different ways that you can see this, maybe with desktop. Just looking for a computer. Well, doesn't have it. Well, guys, here it is. You see, every computer has this, right? And to transmit data, they're gonna use a certain protocol and a certain layer. Okay, this guy is using the transport layer, right, to transport information from one computer to the other, like this, right? This is virtual. You don't see this, right? But every computer has this. in every computer component, there's these layers that are there. And every layer has to do with something, right? There's certain elements like elastic load balancers. They use specific layers to work. When we get there, I'm going to show you this a little bit more in AWS. But for now, you need to understand that there's 7 layers that are used when transferring or communicating between computers and with computers between them. Okay, that's networking. Okay. And I like this image, guys. I'm gonna take a picture of this image and post it on Slack. So I'm gonna open Slack here. And then I'm going to post that image. Okay. Perfect. So Amazon VPC. What is a VPC? It's a logically isolated section of the AWS cloud. In other words, it's a portion of the AWS network. Okay, it's a portion of it that you are separating for your resources. Okay, you can launch resources inside it, right? You can launch public and private resources, right? You can have subnets, you can have NACLs, you can have VPC logs. Okay, when I said NACLs, guys, do you hear my fan? Does it make any sounds, interference?
No.
No?
No, it's fine.
Okay. I didn't want to interfere with sound. It's just I'm a little hot here. Okay. So you can launch resources and you can have control over your virtual networking resources. Remember that VPC, well, VPC is you're responsible for the configuration of your VPC. Okay. For creating subnets, for securing your VPC, your network. You're responsible for that. Amazon VPC is free. You don't have to pay for it, right? You can have up to 5 VPCs per region, okay? Up to 5 VPCs per region. That is the default value for a new account. So let me take here, limits, VPC limits. VPC limits for AWS new accounts or for new AWS accounts. Okay, so you can have up to 4, okay, 5 Amazon VPCs, elastic IP addresses. Let me take a look at the quotas. You can have 5 VPCs per region. That's the default, and you can have up to 100 VPCs per region. So the default is 5. This is a soft limit, right? It's something that you can increase by calling AWS, contacting AWS, right? And then you can have up to 100 VPCs, okay? Per region. So you can have 100 in another region, right? For now, you can only have 5, okay? If I try to get more than 5, I would get some problems here, okay? In one region, I'm talking about one region. All right. You can have up to 200 subnets per VPC as well. So this is something that you guys can research later, do some research on, and networking limits in AWS. You can select the IP addresses range. We did select the ranges, the CIDR. Remember the CIDR, the classless interdomain routing. We can select the subnets, configure the route tables and network gateways. We can enable the customization of the network configuration for our VPC, and we can have multiple layers of security. Okay, so we can do all this with VPCs. Okay, so VPC is logically isolated from other VPCs. Every VPC it's private on its own. Okay, it's just isolated from the other VPCs, but they can be connected through something called VPC peering. You can peer the VPCs, so resources in one VPC can connect with resources in another VPC, but that has to be achieved with VPC peering. You know, other than that, you cannot connect. I mean, there's no connection between them. Okay, they are isolated, and they're dedicated for your account. They belong to a single AWS region and can span multiple availability zones. As you can see here, there are 2 availability zones inside the same VPC, 1 and 2. So you can have several availability zones in one VPC. Don't forget that it all depends on how many regions, how many availability zones the region has. In the case of Northern Virginia, which is US East 1, and if you live in Miami, probably that's the one that shows by default in your account. Probably if you live in another region, like I would say a little closer to Ohio than Virginia, then it's gonna show Ohio, which is US East 2 or US West 2. Let me check. I don't know the codes by heart, but you can say East 2 is Ohio, and then California is West 1, and Oregon is West 2. Okay, good. So it's gonna place you in the one that is closest to you. In my case, by default, it shows Northern Virginia because Miami is closer to Northern Virginia than Ohio, US 2. Okay. You can have in the Northern Virginia region, you can have up to 6 availability zones because that's the number of availability zones that this region has. Okay. Subnets is a range of IP addresses that divide a VPC. And what is the purpose of a subnet? Well, segment your network. Segment your network and organize it better, right? Imagine if I don't have subnets, where will I put my private resources? Where will I put my public resources? It's gonna be a mess, chaotic. So if I have subnets, I can organize and think that these resources can be public can be public in the internet for everyone to access it. So I want to put them in a public subnet, right? But I don't want this particular database to be accessed by anyone. I would put them in a private subnet and no one will be able to access it. No one, okay? Now, a subnet belongs to a single availability zone. They cannot have the same CIDR. Remember, they cannot overlap. Let's go back to VPC here. They cannot overlap. If you take a look at the CIDRs of these guys, you see that they don't overlap. They have a different CIDR. They have the same notation, 24, but they have 2, 3, 0, and 1. Okay? They cannot overlap, right? And classify as public or private. Okay? If you have another VPC, guys, you can have this as well, 2, 3, 0, but they cannot be in the same VPC. They cannot overlap, okay? I can create another VPC and create subnets with the same CIDRs. It's not a problem because they are in a different VPC, okay? Good. Now, when you create a VPC, you're assigning...
Question.
Go ahead, please.
And when you see if you create another VPC with the same subnet, could that VPC be in the same region?
What do you mean? Ask me again.
All right. Go back to your AWS account, your console.
Yes.
So right now you're in the region Northern Virginia.
Yeah, you don't choose the region when you create a VPC because they're already in this region. You can only have 5 VPCs in one region. If
Okay.
I want to create another VPC in another region, I will have to change the region. Then when I change the region, I can create, these are the ones that I have by default, because remember, Ohio only has 3 availability zones. That's why you see 3 subnets here. You see 2A, 2B, and 2C. If we go back to Virginia, the default ones is one E, one B, one A, one D, one F, one C, because North Virginia has 6 availability zones, right? And it's 1 subnet per availability zone. That's what it does by default. I can have 3 subnets in one availability zone if I want to, okay? But if I want to create another VPC in another region, I have to create it, okay? And then I will go ahead and create a VPC here, right here, right? I only have the default one, right? Then I will have to create another one, okay? This one, I will create one here, and then I do go through the same process as the other one. But a VPC is inside a region. They belong to a single region, okay? It's a regional service, okay? Don't forget that, regional service. You take a look here. It's a regional service. It belongs to a single region. VPCs that you create in Northern Virginia will not be visible in Ohio because they don't belong to Ohio. They belong to Virginia. Do you understand this, Sean? John, do you understand what I'm saying?
Yes, I get that part. But what I was asking is if you could create another VPC in Virginia and give it the same subnet range as the other VPC.
Let's do it. Let's do it. Okay. So I'm going to say my second VPC. Right? I could create it, right? In Northern Virginia. Now, if I take a look at my VPCs, I have 2. My second VPC and my MDCC VPC, right? Now I can create subnets. I would create only one, okay? I don't want to have many subnets here. I will create one subnet and I'm going to select my second VPC, right? Now I'm going to say my second VPC public subnet 1, okay? Now I'm going to do it in the same availability zone, right? And the site is going to be 10.0.0.0.24. Okay. Remember, this belongs to this particular VPC. It has nothing to do with the other one. So they will not overlap because they are in a different VPC, right? So I can do exactly the same in every VPC and there will not be any overlapping. Let me take a look at the subnets.
Okay, thank you.
You see this .0.0.0 and this one .0.0.0, but they are in different VPCs. It doesn't matter. Well, the problem is that they cannot overlap in the same VPC. Within the same VPC, you cannot have the same CIDR. You have to change the CIDR. And what do you change? How do you change CIDR? By changing this number, okay? Which is the subnet number in this VPC. Okay. You get it now?
Yes, I do. Thank you.
Let me delete this guy because I don't want to have many VPCs here and VPCs and subnets. Okay, so now I'm gonna delete the VPC that I just created. This is free, guys. I don't get charged for this. I'm just, I don't want to have this mess here. Okay, good. So You create an IP address, and then you give it a CIDR, and 16 is 65,533, just like I did here, right? And then 28 would be 16 addresses, just like I did here. 28, 16, right? And that's the maximum you can go, and this is the minimum you can go. Okay? If you create a VPC, this will not be accepted. This will not be accepted. This. Okay? I try that. Let's see what happens. You see? It can only be between 16 and 28. What if I do this? You see? Same thing. Okay? But what if I do 16? Perfect. 16 is fine. Okay? Any number between 16 and 28. Any number we're fine. Okay? You cannot change the address range after you create the VPC. Guys, make sure that when you're creating a VPC, you allocate enough IP addresses for future use. Because once you create the CIDR, once you can create the address range, you cannot change it. You will have to recreate the VPC. You will have to delete and recreate the VPC. Okay? Very important. You can go 16, 28. It also supports IPv6. We show that. And the subnets blocks cannot overlap. We saw that too. Okay? Things that you're learning. You guys learning? Yes or no?
Yes.
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 Good to know that. Okay? Very good. Reserved IP addresses, we talked about this already. When you create a VPC and subnets, right? And the subnet has like this CIDR, 10.0.0.0/24. That's exactly what I created here, guys, in my subnets, right? That's exactly what I created here. This is the CIDR for my subnets, right? AWS will take 5, just like we saw before. We take 5. Okay. And here, 20 will be how many? What is 20? Let me go back to my 20 is 4096, right? But here we have 4091 because AWS takes 5. Don't forget that. It should have been 4096, but now it's 4091. Okay? AWS will always take 5 IP addresses for every subnet, no matter what. Okay? The first one is for the network address. Second one is internal communication, right? That's the router, the VPC for the IP for the router VPC or the VPC router. This one is for the DNS server for future use and the broadcast address. Guys, you don't need to know what this is addressed for. You just need to know that AWS will take 5 IP addresses from every single subnet when you create it. No matter the CIDR you give it, no matter the notation you choose, right? If you choose 28, every single subnet will have 11. Okay? If you write 23, every single subnet will have 507, right? So it's going to take 5 all the time. Okay? That's something you need to understand. Public IP address types. We can have a public IP address, IPv4, and we have an elastic IP address. The good thing about elastic IP address is that you can use it, reuse it, and you will never lose it unless you release it. Okay? When you create an EC2 instance, you will be assigned an IPv4 public IP. Okay? That's going to happen. Okay? It's going to be manually assigned through an elastic IP address, okay? And automatically assigned through the auto-assigned public IP address settings at the subnet level, okay? You'll always be reassigned one. Now, the difference between them is that Elastic IP address can be associated with an AWS account, can be allocated and remapped anytime. Additional costs might apply. The first one is free as long as it is attached to an EC2 instance. The rest of them are, you have to pay for them. You can have up to 5 Elastic IP addresses per region. Okay, so let me show you this. Let me create an EC2 instance. Okay, let me create an EC2 instance. I don't have anyone running now. Let me launch one. Real quick, just real quick. I'm gonna just skip through the steps, right? I'm not gonna select anything. I'm gonna leave the default settings here, right? But in this section here, you have an auto assign public IP. It's enabled by default. Okay, it's enabled. I will enable now. Okay, not a problem. I will continue. Continue. Security group, I don't care about that now. I just launch it. Okay, I launch it now. Right. I launch it. I'm not gonna choose any keys. I don't care about the keys now. The keys are the ones that let me sign into my virtual machine. I don't need that now. Okay. Now, I have an instance here that is pending. It will be running in no time. Okay, let us wait. You see here that it's being assigned a public IP address, right? It's running now. Perfect. Now this IP address, guys, let me take a picture of this IP address. I don't want to lose this for you guys to see what's going to happen here. Okay. So I'm going to bring it here and put it here. Okay. I'm going to stop my EC2 instance. I'm going to stop it. Okay. So let me go here and stop it. Okay. I will stop it now. Instance state, stop the instance. Perfect. Okay. I'm going to bring this guy here. And what I'm going to do is just open this guy. Right. I'm going to bring it here. And then I'm going to say left. And this one is going to be right. Okay. Right. So my instance right now is, if I refresh the page, stopped. Okay. My instance is stopped. You see, it lost the IPv4, public IP. It lost it. It doesn't have it anymore. Okay. Now, if I just start this instance again, I will start the instance, right? And I will come here again, right? I'll take a look and just refresh this page, and I'm going to be assigned another IP address. Let's wait for that to be running. Okay. It will show another IP address here. Okay. Let me refresh that. It's running now. I have an IP address. Guys, compare this one. One moment. So compare this guy with this guy. Is it the same? Is it the same? This guy here with
No,
the
of course not.
No.
they're not
No.
the same, right? So every time you stop your instance and restart your instance, you're gonna be assigned a new IP address. That happens all the time. Now, what I can do is come here. If I want to keep the same IP address no matter what, I have to create an elastic IP. Okay, so I'm gonna create an elastic IP. It's going to be taken from the Amazon pool of IPv4. I'm going to allocate it. It created an IP for me, right? Now I'm going to associate this IP address with an instance, okay? And the instance is going to be this one that is running, okay? Now I'm going to associate it. Now, if I go back to my instance, again, I see that my IP, Elastic IP, has been associated. Now, let's take a picture of this one as well, because I'm going to stop it, right? I'm going to stop it. Right? Okay. I'm going to stop this guy, right? Gonna open this guy. And then I'm going to say left. And then I'm going to say right for this one. Perfect. Now I'm going to stop the instance. Let's see what happens. Now the instance is being stopped. It changed from running to stopping. You see, I haven't lost anything yet. I just keep it because it's elastic, right? My instance will be stopped soon. Okay. Stopped. You see, I kept it. Now I'm going to restart this instance and it will be running in no time. You see, I still keep the Elastic IP. I'm not losing it. Okay. Okay, it will be running soon. Running. You see how cool this is? I never lost my IP address. It's right here. Same thing here. You see? I never lost it. Why? Because I have an Elastic IP address. So now I can disassociate that Elastic IP address. I can come here and disassociate it. Okay. I can disassociate it, and it doesn't belong to that instance anymore, right? And I can remap it to another instance if I want to. Okay, so now I can come back here, and you see, I was immediately assigned a different IP address because the Elastic IP address was disassociated. What I have to do now is come back to here to the Elastic IP and release it because I don't want to have it. I release it, boom, and it's gone because I will be charged if I don't use it. If I don't associate it with a running instance, I will be charged. Okay, so I'm gonna come here and terminate the instance because I don't want to use, compute hours just for nothing. So this would be terminated in no time. It's just shutting down now. Okay, guys. So you see how Elastic IP works? Do you guys understand how Elastic IP works? Yes?
Yes.
Okay. So an Elastic Network Interface it's a virtual network interface that you can attach to an instance, detach from the instance, and attach to another instance to redirect network traffic. Guys, Elastic Network Interface is similar to a NIC card in a computer that it allows communications, traffic, network traffic between subnets. Because you put it in the subnet, right? And you can attach it to an instance or detach it to an instance. Sometimes you have to mount things like that, like an Elastic file system is going to be mounted on a network interface, right? So it can work in a subnet. Its attributes follow when it is reattached to a new instance. So everything that comes with the network interface, the Elastic Network Interface, or ENI, also known as ENI, all of the attributes that ENI has will follow when it's reattached to a new instance. Okay. Every instance in your VPC has a default network interface that is assigned a public or a private IPv4 address from the IPv4 address range of your VPC. Okay. So when you move a network interface from one instance to another, network traffic is redirected to the new instance. Okay. So all of, when you create a VPC and you put an instance in a VPC, that will be assigned a private IPv4 from the IPv4 range of your VPC. That's going to happen. Okay. Route tables and routes. Okay. Every subnet has a route table. No matter what, every subnet has a route table. There's a default route table, right, that contains an entry which is 10.0.0.0/16. That is the CIDR of your VPC, and that is the local traffic. That entry with a destination and a target, it allows the traffic to flow within the VPC. Okay? If you take a look at my VPC here, let's look for the VPC and let's see the route table. Route table. We have a default route table, right? It has a local entry, okay? That's what happens when you create or when the account is created. It creates a default route table. What is the best practice? Create your own route table, okay? Create your own route table. That is called a custom route table, okay? This is the one for the default one, and the other one is for the one that I created. Remember that I created a VPC. Don't forget that, okay? So you can create a route table, name it public subnet route table. And then you can use it for my VPC, right? And that's going to be my Saturday NDC VPC, right? And I'm going to name it a name, the public subnet 1 route table. Okay, so I have my first route table here. Okay, beautiful. I can do the same for every single subnet. Okay, it's not the main one, it's just a custom one. Okay, I can create another route table. Okay, and that's going to be for route table 2, VPC this one, and then the name, this one, and this was going to be 2, right? Here's the other one. Now I'm going to create another one, and that's going to be my private subnet route table. 1 route table. I'm going to use the same VPC name, and that's going to be private. Okay. And then I'm going to create another one, and that's going to be my private subnet 2. Right? The VPC is going to be this one. The name is going to be this one. And then I have my 4 route tables. Okay? My 4 route tables. The custom ones. Okay? Perfect. Okay? Perfect. If I take a look at every route table, routes, all of them, they have the local one. Okay? All of them, they have the local one. The local one will always be there. That is the one that it is created by default, right? And, you know, it allows the traffic internally in the VPC. Okay? So I have an internet gateway that is provided for me, right? Provided for me to my default VPC. I'm going to create a new internet gateway. So I say my Saturday MDC internet gateway. So this is the one that would allow the public subnet to communicate with the internet. Okay. Perfect. So I'm going to create the internet gateway, right? Now I have two internet gateways, the default one and my default internet gateway. Okay, I'm going to come to my subnets, right? My route table, and I'm going to bring the first one that's public, and I'm going to say edit routes, add a route. I'm going to say 0.0.0.0, which means the internet. And then now I'm going to say the internet gateway. And that's the one. What happened here? Oh, so I'm going to come to the subnet, public one, the public one, and I'm going to edit route association. So route table ID is going to come with the public. Okay, this one is the, okay, a moment. This was public subnet 2. I'm going to talk about public subnet 1 first. Okay, so I'm going to route table. Okay, I'm going to edit the route table association. I'm going to communicate with the public subnet route table, and then I'm going to save this. Okay, so this subnet is connected to the route table 1. Okay. Okay. Route table 1. Now the route table 1 subnet association, okay, is associated with this subnet. Okay.
I am completely lost.
Huh? Okay.
I am completely lost.
Okay. Every subnet has a route table, right? Every subnet has a route table. The public subnets, they have to be connected to the internet gateway. That's the only way that they can connect to the internet. And the only way that you can connect the public subnets to the internet is just by attaching the internet gateway to the sub-public subnets. It's the only way. How can you connect to the internet if you don't have an internet gateway? You can't. Okay? So you have to associate the route table with the subnet. Because you create a route table, but the route table is created, there's no association with any subnets. So what I did, I edited association and added this one, which is the public subnet, the public subnet 1 with the route public subnet 1 route table, because I'm using this route table with this subnet. I'm going to use another route table with this subnet and another route table with this subnet. Every subnet has a route table. Can you understand what I'm saying?
Yes, I follow that part.
Okay. So this subnet here, it's already associated with, let me see if I can see the subnet, associated with this route table. Okay? It's associated already. Now the route table has some routes, right? Now what I have to do is add, let me see if it works now, because It is not working before. It's not working. I have to see what's going on here. Okay, let me do something here. I don't know if I can. I don't have a board. I wish I could have a board so I can explain this better. Okay. So you have what to insert an image. So we have, right, this one. And then we have Subnet one, right? Let's say public. Subnet one, right? We have public Subnet 2. Right? That's in another AZ, okay? And then you have public Subnet, private Subnet 1. Right? And then private Subnet 2. Right? So far, so good? Okay, so this is what is C1, right? Right? And this is AC2. So far, so good, guys? Okay.
Yes.
Yeah. So every subnet has a route table, right? That's something that will always be there, right? Right? That's something that you have to create, guys, okay? Right? Now, the route table has an entry, which is 10.0.0.0.16, which is the local entry. Okay, that's going to happen all the time. So because that's the one that allows traffic inside the VPC, right? That's the local traffic. Okay. Okay. Now these two guys, what makes these two guys public is not the name. It's just that there's another entry in the table that says 0.0.0.0, which is the internet, every single IP in the entire world, and then it's going to come from the internet gateway. Okay? That's what makes this subnet public. Nothing else. It's just that. Okay? So that's going to be, this is, okay? So this is going to be the destination, and this is the target. The target is local, the target is the internet gateway. Okay? That's how you can put now something here, like an instance, a web server, a database, and a database. There's no communication from the internet with these guys because it doesn't have this entry, which is the one that allows internet connection. The internet gateway is the one that allows for the internet connection. It's the only one. And what I was trying to accomplish here is just associate the route tables, the public ones, with the internet gateway. Okay? So it can communicate to the internet. Okay? And then later, I can put, when I create the instances, in the EC2 instances, I can put my instances when I launch them, right? First step, second step. And here, I can put the instances whenever I want. So I can say the VPC is this one. And here I can put my instance, the web servers, in the public subnet. You see? And then when I create another web server, would be in the public subnet 2. And then if I create an application that is confidential, I put it in the private subnet 1. And then in the other AC, I put it in the private subnet 2. You see? That's how it works. First, you create the subnets. You create the route tables. Associate with the route tables with the subnet. Put this entry in the public subnets for them to communicate with the internet. And after that, you create your instances and put them whenever you want. Then your instances here, we have communication with the internet. And your instances here will not have any communication with the internet because they were put in a private subnet. Okay, that's how it works. Do you guys understand it a little bit better now?
Yes.
Yes, yes.
That's right.
Oh, sorry, Damien, go ahead.
Could you just go back to the diagram, please, so I can write it down? Or let me take a screenshot, please.
Yes.
Professor, what I wanted to know is when would you need to put an instance in a private subnet over a public subnet?
A database.
Okay.
A database and an API. You don't want people to access the API directly. You want people to access the API through the front end.
Okay.
You have a full stack application. You have, front end, a middle tier, and the back tier, like a 3-tier application architecture. Front end, middle tier, back end, things like that.
Mm-hmm.
You don't want that application that has all the data, that works with data, exposed to the internet. So you want that to come through a web server. Then the web server will request information from the resources in the private subnet.
Okay.
Right? That does answer your question?
Yes.
Everything that has to do with confidential information, you don't want to put them in the public subnet because they're exposed to the internet. You don't want that. Okay? But guys, what you have to remember is what makes this subnet either public or private is not the name, because you can name it anything you want, is the connection to an internet gateway. If there's an entry in the route table to the internet gateway, there's no connection to the internet. And that makes it a private subnet. So it says here, by default, every route table contains a local route. We saw that already. And each net must be associated with a route table. At most one. It's only one. Okay? It's only one. Route table per subnet. Okay? VPC is a logically isolated section of the AWS cloud. VPC belongs to one region and requires a CIDR block. A VPC is subdivided into subnets. A subnet belongs to one availability zone and requires a CIDR block. Route tables control traffic for a subnet. Route tables have a built-in local route. You add additional routes to the tables, and the local route cannot be deleted. Okay, that's the one for default. If you delete that one, if you could delete that one, there's no traffic within the VPC, and that cannot happen. That cannot happen. VPC networking. So we have an internet gateway here. Okay, like I said before, you see here, this is the entry that we were looking for. Okay, this is the entry we're looking for. So this public subnet has access to the internet because it's connected to the route table and to the internet gateway. This guy has no connection to the internet gateway, so it cannot connect. Okay? We will know about a NAT gateway. A NAT gateway is what allows private subnets to connect to the internet, but that's going to be later. Okay? For now, understand that you can only connect to the internet gateway, to the internet through an internet gateway. It's the only way. Okay? And that has to be reflected in the route table. Okay? Now we have the NAT gateway here. The NAT gateway is the element, is the device that allows for your private subnets to communicate with the internet through a NAT gateway. And NAT gateway, what it does, it just translates the IPv4, the private IP that this guy has, and makes it a public IP, but only through the NAT gateway. Okay? Network address translation, that's what it stands for, a NAT gateway. You put the NAT gateway in a public subnet, and the NAT gateway will allow these guys to communicate with the net. So this will be your route table entries in your private subnet. You see, the public is connected to the internet gateway. The private is connected to the NAT gateway. And guess who is the NAT gateway connected to? Because if this one connects to the NAT gateway, how the NAT gateway connects to the internet? Because the NAT gateway is connected to the internet gateway. That's the only way, right? So the NAT gateway is connected to the internet gateway, and the private subnet is connected to the NAT gateway. Okay. So in other words, it comes this way, right? And then this way. You see, the private instances come to this route table, and then the route table has an entry and a target, the NAT gateway, and the NAT gateway has a target, which is the internet gateway. And then you can update, you can upgrade, you can download updates, softwares for your instances through the NAT gateway. Because these guys, even though there's no communication with the internet, they will need at some point to update, upgrade, download, and things like that. So they communicate with the internet, but the internet cannot communicate with them. Okay? They can't communicate with the internet because they have the NAT gateway, but the internet cannot communicate with them. They can't. Okay? Because there's no, go ahead.
So question then. Are you saying that the traffic for the private, for an instance on the private subnet to get access to the internet, it goes to its private route table, and that private route table then goes to the public route table?
No. Every single subnet has a route table, right?
Correct.
The private subnet will work with its route table, not another route table, with the private route table. But the private route table contains an entry that points to the NAT gateway. So the traffic that comes from these guys to the NAT gateway, to the route table, would then move it to the NAT gateway. Guys, this is all about security groups, okay? In the security group is when you establish this, right? The security group is the one that allows traffic. The security group of this guy would allow traffic from here to here. Because, I mean, you can have a route table here, right? That has this entry. But if the security group of this instance doesn't allow communication with the NAT gateway, it will not communicate with it. Remember that every instance has a firewall, which is a security group. The security group has to allow the traffic from the NAT gateway and to the NAT gateway. Okay? So in other words, we put a NAT gateway here. Okay? NAT gateway. Right? And then we're going to say that, like it says here, right? We're going to say that this, we're going to have in a route table here. Our next is going to be 0.0.0010. I'm sorry, 0, and then NAT gateway. Something like that. Then the traffic from here can go to the NAT gateway and then communicate to the internet. Okay, but that's going to be in every, remember, John, you have to have routes in every private, in every route table, right? This one, if this one doesn't have this entry, will not be able to connect to the NAT gateway. Every route table is private of its own. Every subnet has its own route table. You have to update all the route tables for traffic to move. Okay? The fact that you update it here, it doesn't mean that it's gonna be updated here. So you have to put the entries. You have to add the entries manually for that to move. Okay?
So question.
Go ahead.
Go back to your diagram. So you configure the NAT gateway in the public subnet route table.
Yes.
And then when you configure the NAT gateway, when you put the NAT gateway entry in your private subnet, it then contacts the NAT gateway in the public subnet, public route table.
First, no. It has nothing to do with the route table in the public subnet. The route table that counts is the one in the private. This guy here, this route table here, okay, what is this? One moment, please. This route table here is for the communication with the internet. This route table here. Okay, this route table has nothing to do with this route table. These entries are different from this one. This is for communication with the outer world, and this is for communication with the NAT gateway. So when the traffic comes from here to here, the first thing that it does, it checks the route, right? The routes. If it has a target NAT gateway, it will look for that ID. The ID that you have here is an ID. The ID comes through here, and this one has connection to the internet. It doesn't check the route table of this public subnet. It just comes to the NAT gateway, and the NAT gateway goes out. The NAT gateway has nothing to do with the route table. Route table is for your resources here. The NAT gateway already has connection with the internet. I don't know if you understand what I'm saying.
I think so. I think the challenge I'm having is that because you have the NAT gateway written in the public subnet 1.
Yeah, I haven't put it in the next subnet 2 yet. Okay, I just have it here for communication of these resources with the internet.
Okay, so anytime there's traffic from private subnet 1, and it has to go to the internet, it contacts the NAT gateway in the public subnet 1?
Correct. But it has to have the entry in the route table. If it doesn't have this entry, it's useless. You're not doing anything. The route table has to indicate that the traffic is allowed to go to the NAT gateway. And once you go to the NAT gateway, you have internet connection. Okay? So here we have VPC sharing. You have a private subnet here. And then you have a public subnet. You have account B, account C, account D, right? Different accounts, right? Account B has EC2 instances, and account C has EC2 instances and RRDS. You see? This is a private subnet. And a public subnet, we have a NAT gateway, we have an EC2 instance that's probably a web server, and we have an Amazon Redshift, which is a data warehouse. I still don't understand why you would put a data warehouse in a public subnet, because it's something that has to do with data. But that's the way that AWS put it here. Okay. So this is the owner of the account, and this is how you are sharing the VPC with multiple accounts. Okay. So you have the router here as communicating, the route table communicating with the internet gateway. And then you have these guys here, right? You have a NAT gateway here. Right. Similar to what we saw before. So now we have VPC peering. That's the way that you can, connect to VPCs, right? So we have the first VPC is connected to the second one. Okay, once you have that connection, it means that you can, resources here can communicate with the resources here. Okay, and how do you do that? Well, you have a route table for VPC A, and you have a route table for VPC B. You have the local traffic, but you can say, well, I want to have an entry, which is the destination, this VPC, and then the ID of the peering connection. Okay, then this VPC will be able to communicate with this one. But this one cannot communicate with this one until I update the route table for VPC B. So they both have to be updated. This is a two-way connection. Okay. Do you guys understand?
Yes.
Yes.
Okay. That's VPC peering. Okay. Site-to-site VPN. This is something that, first of all, it needs the internet, right? VPN, a virtual network, virtual private network. You need a VPN, you need internet to connect. And that's when you want to connect the on-premises data center with the cloud. Okay? There are two elements that you need. You need a virtual private gateway, and you need a customer gateway. Okay? You need the site-to-site VPN connection. That's just similar to this guy. You need a connection in between, right? And in this case, it's going to be a site-to-site VPN connection, right? And basically, what we're trying is to connect the corporate data center with the cloud. Okay? So the private subnet here has a route table that has an entry to the virtual gateway. The virtual gateway, it has a connection with the site-to-site VPN connection. And then you need the internet for that. That is also connected to the customer gateway, right? And then the customer gateway is connected with the corporate data center. So this is how it's going to happen in your public subnet route table. It's going to have a local entry and then one to the internet gateway, right? And the private, of course, guys, we don't see the internet gateway here anywhere, but we're just trying to imagine it. We're just focusing on the private subnet. The private subnet has a local. Remember that the local entry cannot be deleted. And then it has a destination, which is the IP address of the corporate center. And the target's going to be the virtual gateway. Okay? That's why route tables are so important, because that's what allows the connection. Okay? That's what allows the connection. I hope you guys understand this here. Okay? Because it's the same concept that we applied before. Okay? Same concept all the time. Here, the destination of the target. Same concept all the time. Destination on target. Okay? Every subnet will always have a route table. It has to be associated with a route table, and only one route table. Okay? That's how you connect the corporate data center to the cloud by just using a site-to-site VPN connection. And then on one side of the cloud side, you have a virtual gateway. On the customer side, you have a customer gateway. Okay. Now, this is another way to connect, but this one doesn't need the internet. VPN connection needs the internet. This one doesn't need the internet. Okay, which makes it more secure, because you know when there's internet, there's more exposure, the more probabilities of attacks. Okay, so in this case, we also need a virtual private gateway, a virtual gateway, and a customer gateway. But you have a AWS Direct Connect section here. This is a dedicated team for you guys, and it doesn't traverse the internet. It uses private links that are fiber optic. Okay, so you can communicate with the cloud right from the corporate center just using fiber optic. Okay.
Would that be an MPLS link?
I'm sorry?
Would that be an MPLS link?
MPN?
MPLS. Between the virtual gateway and the customer gateway, would that be an MPLS link? Fiber link.
It's private links. It's just known by AWS using a fiber optic. Private links. Let me check here. Okay, AWS private link enables you to connect to some AWS services hosted by other more, please. Hosted by AWS accounts referred to an endpoint services and supporting AWS Marketplace partner services via private IP addresses in your VPC. Let me see Direct Connect.
Don't worry about it. Don't worry about it.
Maybe I'm just
that's going into underlying connectivity, which I don't think we really need to know for this course.
I'm gonna post this. Maybe guys, you can have some answers, some questions answered. This is the Direct Connect frequently asked questions. Okay. So VPS endpoints, right? This is another way to connect, right? VPS endpoint is a virtual device that enables you to privately connect to VPC, to your VPC to support it, AWS services and VPC endpoint services that are powered by AWS private links. You have interface endpoints and gateway endpoints. So for interface endpoints, you have it's powered by AWS private links. And for these guys, you have Amazon S3, you have DynamoDB, which are some of the services that are not subjected to a VPC. They are not in the VPC. They are outside, okay? So in the case of this public IP route table right here, they want to connect to an Amazon S3, right? So you have to create a VPC endpoint, right? And then mount this communication with an elastic network interface, right? And then the route table of the public is going to be the VPC IP ID, which is this one, of this guy. and the destination is going to be the S3 bucket. Okay, so these guys will communicate through the Elastic Network Interface, and then the Elastic Network Interface is connected to the VPC endpoint, and then the VPC endpoint is connected to the service that you're trying to communicate with and get access to. Okay, you can either use the default DNS hostname or the endpoint-specific DNS hostname. All right, this is more advanced. This is seen from a more advanced endpoint or perspective in the solutions architect exam. Here, you just need to understand that there's VPC endpoints that are interface endpoints and gateway endpoints, two types of endpoints, right? And the end of these guys is just communication between services. That's the end goal of these guys. Okay. The transit gateway, this is a very good service that allows all the services connect. It's like a hub that has different ports, and you can just connect all the devices to the hub, and then all the devices are connected right away. It's similar. Instead of peering every single VPC to each other, like peering VPC A with VPC P, peering VPC B with VPC C, C with D, all that, why not connecting all the VPCs to the transit gateway? And then all the VPC will be connected. Okay? So this is a lot of work here. This is a lot of work. The best practice and the good thing is have all this. You see, you have the AWS Transit Gateway, and you have AWS Direct Connect, VPC, the VPN connection, and all of them are connected because this serves like a hub. Okay? Where you can have all the devices connected, one with the other. Okay? That's the AWS Transit Gateway. All right, let's label this network diagram. Okay? So guys, what is this? What is this? What is this? We have the cloud, and then inside the cloud, what is the biggest thing here? What is this?
It's a region.
It's a region. But no answer. Region, right? What is this? Inside the region, what do we have?
Availability zone.
Availability zone. Remember, this is it that has this and this. What is this?
Oh, that's the VPC.
A VPC, right?
Mm-hmm.
Guys, the only student that I have here is John.
It's Damien.
I'm sorry.
It's okay, John.
No,
Well, my voice, his voice is different. So, if I do this, I get all these guys here. Take a look at it. Okay, so we have all these guys here. Let's watch a demonstration on VPC. Okay.
Hello. For this demonstration, we're going to be creating a virtual private cloud, also known as a VPC. One of the first things you need to do is once you log into your AWS Management Console, you need to select the region you wish to deploy your VPC in. Once you've selected your region, you can type VPC in the search bar or scroll down to Networking and Content Delivery and select VPC from the menu. This will bring up the VPC dashboard. Here we want to select Start VPC Wizard. In the VPC wizard, we have one of 4 options. You have a VPC with a single public subnet. You have a VPC with 1 public and 1 private subnet. A VPC with 1 public, 1 private subnet and hardware VPN access, or a VPC with 1 private subnet and hardware VPN access. For this demonstration, we're going to create a VPC with 1 public and 1 private subnet. Click on the Select button in the middle of the screen, and it'll bring us to a window where we have the information we're going to put in for our VPC. The first item is the IPv4 CIDR block range for the VPC as a whole. As you can see, the default is a 10.0.0.0/16, which gives us a total of 65,531 IP addresses that we can divide up among multiple subnets. For this demonstration, I'm not going to use IPv6 addresses, but we do need to give it a name. Next, we have our public subnets IPv4 CIDR block, and you can see the default is a 10.0.0.0/24, which will give us 251 IP addresses to use in our public subnet. At this point, we can choose which availability zone we want to put our subnet in, or we can let the system choose. I'm going to go ahead and choose US West 1A. We also have the option of changing the public subnet name, but I'll leave it as the default of public subnet. And now we can look at our private subnet's IPv4 CIDR block range. The default, as you can see, is a 10.0.1.0/24, which gives us 251 IP addresses to use in our private subnet. I'm going to go ahead and deploy my private subnet in the same availability zone as my public subnet, and I'll leave the default private subnet as the name. Now we have a choice whether we want to use the network address translation gateway or the network address translation instance. In most production environments, I would recommend the network address translation gateway, but for the sake of this demonstration and because it creates it slightly faster, I'm going to go ahead and use the network address translation instance. Once I've selected network address translation instance on the far right, I need to select which instance type. This is going to be the instance size that it will use to do all network address translation for your VPC. In a production environment, you probably wouldn't use a T2 micro, but I'm going to go ahead and leave it at the default for now. The key pair name is if I want to allow somebody to log into the NAT instance. In this case, I'm not going to have people logging into the NAT instance, so I'll elect to use no key pair. If I need to create VPC endpoints, I can do that here, or I can do it later, coming back in and editing the VPC. For now, I'm not going to create any endpoints, and I'm going to choose to enable DNS host names for all my hosts in my public subnet. Hardware tenancy, I can choose the default of shared tenancy or dedicated tenancy. Once you've got all the options set that you wish to make changes to, click on Create VPC, and you can see the progress bar move across, and it's doing things like creating your gateways, creating your subnets, and in this case, running the NAT instance, creating the actual network address translation instance. It takes just a couple minutes. And then you will see a window that tells you that your VPC has been successfully created. If we click on the OK button, it'll bring us to the window and we can see that our demo VPC has been created. We can select the box next to the demo VPC and you can see all the information about the VPC below.
That was a demo on VPCs. So the key takeaways here. Several VPC networking options, which includes Internet Gateway, NAT Gateway, VPC Endpoint, VPC Peering. VPC sharing, AWS site-to-site VPN, AWS Direct Connect, and AWS Transit Gateway. You can use the VPC wizard to implement your design. All of this can be created in the VPC wizard in your account. Right here, by going to the VPC wizard. And then all of these guys can be done here. Route table, internet gateway, endpoints, NAT gateways, peering connections. All of this can be done here. Transit gateway, VPN endpoint, site-to-site VPN connections. Customer gateway should be here some way. Where? Right here. On virtual private gateways. We're not going to be able to finish this today, guys. It's 3:19. It's a long class. So security groups. Security groups act as the instance level, right? A security group, when you create an instance, you can, that's the firewall of the instance. You can limit the traffic, right? It's just here in the EC2 instance dashboard. We can just come here and create a security group, right? I created one before. So when I create the instance, I can simply attach it to my instance as the firewall of the instance, right? I just configure the details. By the way, the system he was using is the old system, is the old console. This is different now, okay? Security groups here, I can just select an existing one. I can choose the one that I created before and then continue. And that will limit the access to only port 22. And I can put the IP address here that I want, that access my account. In this case, this is bad practice because we're using all the IP addresses in the world can SSH into my account. That is not correct. Okay? It's just an example. So security groups, they act at the instance level. Don't forget that. By default, security groups deny all inbound traffic and allowed outbound traffic. That's by default. Okay. They have inbound and outbound traffic, instant traffic rules that you can do that. Okay. All inbound traffic is, like I said before, is denied, and outbound is allowed. But there's stateful. Guys, stateful means that whatever comes in goes out. Okay, that's what it means. Okay, that's why the outbound traffic rules are always allowed, because it doesn't matter when it comes in, it goes out. In this case, it will never go out because it cannot go in. It's denied. Okay, by stateful, what it means is it goes in, it goes out. That's what it means. Okay, it's like I go to your house and I knock on your door, and then you ask me for my ID, right? I give you my ID, I enter your house, I stay inside your house for 3 hours. Then when I come back, I just go out. You don't ask me for my ID again because you already know who I am, right? You keep the state of my presence there, right? That's why it's stateful. Whatever comes in goes out. That's what it means. So you can have custom security groups. That's what I did, right? You can have different types like HTTP, HTTPS, SSH, open the port. You can have a specific IP addresses. This means all the IP addresses. Guys, how many IP addresses can access this instance using SSH port 22? How many instances?
One.
Only one. Remember? Remember this? I can go back. So before I did /32, it was 1. Okay. We also have NACLs. NACLs is Network Access Control List, and they act at the subnet level. Security groups at the instance level. NACLs at the subnet level. It's another extra layer of security for your subnets. Okay. And the subnets, by default, they allow inbound traffic and outbound traffic by default. Okay? So you have to go in and allow or deny. Okay? So they're stateless. And what is the meaning of that? That you don't keep the state of my presence when I enter your house. It means that when I go to your house, knock on the door, you ask me for my ID, I enter your house, stay there for 3 hours, and when I come back, guess what happens? You ask me for my ID again because you don't keep the state of my presence inside. So in this case, whatever comes in doesn't go out. So you have to configure both the inbound and the outbound rules. Okay? With the security groups, you just configure the inbound and that's it, because what comes in goes out. In the NACLs, you have to configure both inbound and outbound rules. Okay, and by default, all the inbound rules and outbound traffic are allowed. Okay, so you can have custom NACLs that deny all inbound rule, like here, deny all inbound rule, right? Until you add rules. Okay, you can specify both allow and deny rules. Rules are evaluated in number order, starting with the lowest number. So if you have allowed in 100 and you have denied in 103, it will be first allowed and then denied. Okay? Deny always has precedence over allowed, but this analyzes by the number that you give it, and it always starts with the lowest number. Okay? And it's good to do it 100 by 100. 100 by 100, just in case in the future you have to add another one between 100 and 200, so you can do it. Okay, so you start with 100, the second one will be 200, 300, 400, and then in the future you need to add 101, you add it there. Okay, that's the recommendation. Security groups versus NACLs. The scope of the security groups is the instance level, like we said before, and the subnet level is for the NACLs. Supported rules allow rules only. NACLs allows and deny rules. Okay, you can put allow or deny, whatever you want. Okay, with security groups, it's only allowed. You open the port and that's it, right? State. It's stateful for security groups. Return traffic is automatically allowed regardless of the rules. And NACLs is stateless. Return traffic must be explicitly allowed by rules. All right. Other rules, all rules are evaluated before decision to allow traffic. And NACLs, they're evaluated in number order before decision to allow traffic. So let's take a look at a NACL real quick before we finish. So I'm going to come here to VPC. Network ACLs. So you can create a NACL. I create a NACL here. Inbound rules. You say allowed or denied. All traffic is allowed, and then deny here. Okay. Outbound rules, all traffic is allowed, then all traffic is denied. So you can edit rules, add rules. You know, add a rule will be 102. For example, you want to custom PCP, port range from 28 to 45, and then deny. It's an example. And then I just have another deny here. All right. And this will work at this subnet level. And then you can have a subnet association here and just put the subnet that you are working with. Okay. In this case, it's for all subnets, right? All these subnets are associated with this knuckle. Okay. So you want to secure just all of your subnets at once. All right. So you have a small business with a website that is hosted on an Amazon Elastic Compute Cloud instance. You have customer data that is stored on a backend database that you want to keep private. You want to use VPC to set up a VPC that meets the following requirements. Your web server and database server must be in separate subnets. The first address of your network must be 10.0.0.0. Each subnet must have 256 total IPv4 addresses, and your customers must always be able to access your web server. Your database server must be able to access the internet to make patch updates, and your architecture must be highly available and use at least one custom firewall layer. Okay, guys? So this is gonna be your homework, guys, if you can do it. Okay. It's 3:30. We have to finish. This is gonna be your network, but above everything, please do the lab. Okay, and the knowledge check, right? Just try to finish this. It only has like 29 more slides. We're gonna continue next Saturday. I'm not gonna stop here, but just if you don't want to wait, you can just go over the remaining slides, do the knowledge check, and the lab. And next Saturday, I'm gonna cover the remaining slides of this lesson. How about that?
Sounds good. Thank you.
Good. Do you have any questions, guys?
Sure, it's okay.
It's fine.
Long class, right here.
Very good. Thank you, Professor.